Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to lesson 27, Triangle Congruency Proofs. So it's more triangle, so if you watch lesson 26, it's more of the same, but different. Okay. What are we trying to prove here? SB equals SC. So I look at this and I see SB right here, and I see SC right here. Well, that is in this big triangle right here, but it's also in the little triangle. So rather than exploding the big triangle, I exploded the little one. So let me move those out like so, and I will label them. And this was B, and this is S, and this is R, and this is R, and this is S, and this is C. So when I do that, it's more clear that RS is equal to itself because of the reflexive property and things like that I look at while I'm doing this. And now I have ABR here. And the reason I'm looking at these triangles is because AB is in this triangle and AC is in this triangle, and RB is in both of them. So I'm thinking there might be some connection since RB is in both triangles. Here, I don't want to explode that. Okay, so I'll put this one right here, and I'll move this one down like so. Okay, so now I want to label those. So this was A, and this was A, and they met here at R. So obviously AR is equal to itself, and this is B, and this is C down here. So then I have RC, which is the same as this, and I have RB, which is the same as this, and that's how they all came together. We do have another set of triangles. We have ABS and we have ACS, but that's the whole triangle, and I don't think we'll need that to do this. So let's prove this. So the first thing we always do is our givens. So I'm going to say AB equals AC, and that's a given. And I'm going to label all my ABs. So AB is here. So that, let me use purple in the diagram. AB is equal to AC. Well, that is in the blue triangle and the red triangle. So AB equals AC. So we have a side. So I will just label one of the two triangles. So we have a triangle congruent set up. So that's an S. So it's not angle, 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 but that would not be congruence. That would be similarity. But anyhow, RB equals RC. So now we say RB equals RC. So we just want to list all of our givens and say given. Now I'm going to label that. RB is right here, and it's equal to RC, which is right here. RB is here, RC is here. RB is right here and right here. So those sides are all congruent because they're all shared by two different triangles. And so now we have another side down here. We have a side up here. Okay. So it's coming together here. So in this triangle here, I would want an included angle if I'm going to do side angle side. So is there a way to prove C is congruent to B and that kind of thing? So, all right, once that's all given, now I can say that AR is equal to itself. So that is the easiest way to prove these two triangles congruent. I'm now going to say AR, let me use black. AR is equal to AR, and that's the reflexive property. Okay, so now I have these two triangles congruent to each other because of side, side, side. See, this is an S, this is an S, and that is an S. Why is that not in purple? Because I didn't choose it. There, S, S, S. Okay, so now I'm going to say that. Triangle ARB is congruent to triangle ARC. The reason, S, S, S. Okay, so now we have these two triangles congruent, and I can label this in the diagram as well. AR is congruent to itself. All righty. And the next thing we're going to do is say the measure of angle ARC is congruent to the measure of angle ARB. Okay, and we're leading up to something here because then we can prove these angles congruent by linear pairs. So I'm saying that angle ARB is congruent to ARC. So angle ARB is congruent to angle ARC. And the reason is, if you look, I'm in the triangle that I just proved was congruent. So that is corresponding parts. Corresponding angles of congruent triangles are congruent, or I like saying parts. So that covers angles and sides. All right, so now we have two triangles are congruent, all their pieces are. So now I can say that this angle A is congruent to this angle A, or CRA is congruent to, CAR is congruent to BAR, and ABR is congruent to ACR. But right now we're focusing on getting over to these two triangles here, because what we're trying to prove is SB congruent to SC. So I somehow have to prove these two little triangles congruent. Okay, so that's exactly what I'm going to do. I now know ARB is congruent to ARC, and then I can say ARB plus BRS is equal to 180 degrees. So angle ARB, so now I'll say, let's change colors to green. Angle ARB, plus, actually the measure of, now we're talking about angle measures, plus the measure of angle ARB plus BRS equals 180 degrees. Reason? They are linear pairs form supplementary angles. Linear pairs form supplementary. Let's see. Okay. All right. The measure of ARB is equal to, or plus the measure of BRS equals 180. I can do the same on the other side. So I'm also just going to squeeze that in here for the same reason. The measure of angle ARC plus the measure of angle ARC CRS. Let me rewrite that. This C doesn't look right. Okay. CRS. And it's the same reason, linear pairs from supplementary angles. Okay, so now I know that these are linear pairs, and so therefore this angle is going to equal that angle. All right, because if this is congruent to this, and this plus this is 180, and this plus this is 180, well, let's just say that this was 120. The only number that would add up to 180 is 60, and therefore this has to be 60. So that's what we're going to say in the next. We're going to say the measure of angle, CRS equals BRS, the measure of angle BRS. Okay, and the reason is that angles supplementary to either the same angle or to congruent angles are equal in measure. Okay, we could say that, or if you look here, CRS, I forgot my equals 180 here. If CRS is here and BRS is here, and we set up here that ARB is equal to ARC, so if something equal is added and we still get 180, then these two angles have to be equal. Hopefully you see that. And let me just bring this in because it's long and my writing is messy. Okay, so that was a lot to write, so I brought in a text box. Angles supplementary to either the same angle or to congruent angles are equal in measure. Capiche? All right, so now we know that these are congruent, so I'm going to label them in my diagram over here. So now I know that this angle is congruent to this angle. So that's an A. So I have an S, I have an A, and oh, now I see it. RS is equal to itself. Reason, same with up here. reflexive property. So now I will label that 1, 2, 3, 1, 2, 3, and therefore in here, and then it's equal to itself. So there we have it. And now we have, I should have used purple. Okay, good enough. That's fine. So now we have two triangles congruent. So now I can say triangle RSC is congruent to triangle RSB. Reason, I didn't put my little label here, that's an S. Side included angle side, so that is SAS. Okay, and now I can state what I'm trying to prove. So here we go. S B equals SC. So these two triangles are congruent now. So SB 1, 2, 3, 4 is equal to SC because corresponding parts of congruent triangles are congruent, or if you prefer, corresponding sides of congruent triangles are congruent. And there we go. Okay, here we go on to problem 2. This one's a little different. We haven't dealt with squares before. And this says, given square, blah, blah, blah. Well, first, let's look at what we're trying to prove. We want to prove triangle ASR is congruent to triangle ESR. So I've color coded those, ASR, ESR. I'm not going to pull these out of the diagram here because it's clear enough what's going on here. They're also saying square ABCS is congruent to square EFGS. So that's the first thing I want to say. Square ABCS is congruent to square EFGS. Okay. Reason given. Okay, so this square A, B, C, S is congruent to square E, F, G, S. This square is congruent to that square. We already know the shape is congruent. So remember, when we have a triangle congruent to a triangle, we can say all of its corresponding parts are congruent, and that's the key here. So what do we know about squares? We know their angles are 90 degrees for starters. And we know all their sides are congruent. And since the squares are congruent, all of these lengths are the same. Okay, so really a lot of information was given to us just stating that these two squares are congruent. All right, so after I say the squares are congruent, let's not worry about this at the moment. I'm first going to state that what is in the triangle that's also in the square, and that is side AS. Side AS is the bottom of this square, and it's this leg of this right triangle, assuming that's a right angle, right? So I'm going to say AS is congruent to SE, or AS equals SE. Actually, let me go in the right order. That's not correct. AS is equal to ES. Corresponding parts should line up in the wording. AS equals ES because corresponding parts of congruent squares are congruent. Okay. Alrighty, so there we have it. So now we have one side of a right triangle. The next thing I'm going to do is say that SR is equal to itself. So if you can see here, they share this side. So SR equals SR, and that is the reflexive property. Oops. Okay, so we have this and we have this. I just need to say that that's a right angle and we're done. So angle BAS and angle FES are right angles. Actually, instead of saying that, I'm going to say angle BAS equals angle FES equals 90 degrees. How's that? Yeah, I'm going to do that. Okay, right angles. We know right angles are 90 degrees. I'm not so picky with my students to say that you can't already know that a right angle is 90 degrees. So angle BAS is equal to angle FES, and they're equal to 90 degrees because angles of a square are 90 degrees. So just definition of square. Definition of a square is a quadrilateral four-sided figure where all four sides are congruent, opposite sides are parallel, and all four angles are 90 degrees. So there we have it. So once I say that, I can now say BAS and SAR form linear pairs. So angle BAS and angle SAR form linear pairs. In other words, BAR is a straight line. BAS plus SAR add up to 180 degrees. So this is def of linear pair. Definition of linear pair. Okay, I can say the same over here. Angle FES and angle SER. That's an ampersand, by the way. Angle FES and angle SER form, look at me with a lowercase, form linear pairs. And it's the same reason. Definition of linear pair. Okay, so once that's all said, I can now say that SAR and SER are right angles. Okay. Reason. SAR and SER are right angles. Well, that's simply because a linear pair is 180 degrees. And since FES is 90, SER has to be 90 because 90 plus 90 is 180. So those have to be right angles. Okay. So that's that really long statement again, two angles. So let me bring that in from the last proof. Okay. So two angles that are supplementary and congruent, each measure 90 degrees and are therefore right angles. Okay. All right, so now if you look, I have a right angle, I have a leg, I have a leg. So we could say the angle SAR, so let's do that. Triangle SAR and triangle SER are right triangles. And the reason, definition of right triangles. And the definition of a right triangle is a triangle that has one right angle in it, 190 degree angle. So now that we have said that this is a right triangle and this is a right triangle, we have a hypotenuse and a leg. Okay, we can't say SSA because that doesn't prove congruency, but we can now say triangle, and they say ASR. So it doesn't matter how I word it. This is ASR here, and this is ESR. You just have to word them. There's many ways you can name a triangle, but they're saying triangle ASR which is the same triangle as SAR. ASR is congruent to triangle ESR, which is what this says. And that's by hypotenuse leg. Okay, there you have it. Okay, page 2 brings us to proof number 3. And I've looked at this and it says prove KX is right here is equal to LY. So whenever we have a side, that's usually where we have to prove the triangle that that side's involved in or part of. So that's why I highlighted these little triangles outside here. So I will slide these out like so and bring them over here and label them as what they were. So this is J up here for both of them. And this was K, and this is X, and this is Y, and this is L. So there's the two triangles. We're trying to prove this little side is equal to this little side. So let's look at the givens. JK equals JL, and I'm just going to write them now. JX equals JY, and the reason is given. So the first thing I'm going to do is just fill in my table. JK equals JL. JK is here, JL is here. That is this triangle to this triangle. And I'll label on the blue one, the blue one. That is a side. Okay. Next thing we know is that JX equals JY. JX equals JY. JX equals JY. Oh, cool. We now have two sides congruent. So I need an included angle. So I guess that I probably have to find the measure of angle J, or in this case, YJL is congruent to KJX, or I should say XJK. Somehow. Okay, so that's our goal. We're trying to prove these two angles are congruent. So I won't label those on the diagram yet because we don't know that for sure. That's what we're trying to do. So that's the given. Okay, so what do we know about isosceles triangles? So now I can say the measure of angle JXY is equal to the measure of angle JYX. I'm looking at this isosceles triangle in the middle. So JXY equals JYX. So the measure of angle JXY equals the measure of angle JYX. And it's because base angles, opposite angles of congruent sides are congruent. So these two angles are congruent. And the reason is base angles of an isosceles triangle are equal in measure. Base angles of isosceles triangles are congruent. Okay, so now I know this angle out here is equal to this angle out here, but that doesn't help us in the triangle yet. All right, so the next thing we're going to say is the measure of angle JXK plus JXY equals 180 degrees. Okay, so JXY plus JXK. The measure of angle JXK plus the measure of angle JXY equals 180 degrees. And that's just simply the definition of our linear pairs are supplementary. Linear pairs are supplementary. Okay. So now I know that this and this are supplementary. So now I know that JXK is equal to JYL. But before I do that, I'm going to say that the measure of angle JYX plus JYL. So now I'm over on this side, the measure of angle JYX. I did JXK, so I'll do JYL first. The measure of angle JYL plus the measure of angle JYX equals 180 degrees. And it's the same reason as above here. So rather than rewriting that, I'm just going to put ditto marks. Linear pairs are supplementary. Linear pairs are supplementary. So now I know that this angle is equal to this angle. Because if this was 70 degrees and these are a linear pair, this would have to be 110. And if this is congruent to that, then this would be 70. So 110 plus 70 is 180. 70 plus 110 is 180. These have to be both 110. And so in order to say that in my proof, though, I have to be able to word that somehow. So I'm going to say the measure of JXK plus JXY. The measure of JXK plus JXY equals 180. Oops. No, I've already said that. The measure of JXK plus the measure of angle JXY equals the measure of angle JYL plus the measure of angle JYX. So in other words, if this is equal to 180 and this is equal to 180, then this is equal to this. Okay, since they're both equal to 180, they're equal to each other, and that is substitution, or you could say transitive substitution. And the reason it could be substitution is because if JYL plus M measure of JYX is 180, I can substitute that in for the 180 up here, and that's how I get that. So either substitution or transitive property. Okay, we're going to do the same on the other side. The measure of JXK. Let me see. Let me think about this one for 1 second. Okay, that was a little tricky. So please, when you're doing these proofs, don't give up. Please try. It is really important that you learn how to problem solve. And that's why we do these. We're learning how to problem solve. We're learning how to come to a conclusion when given a problem. All right, so here we have, I labeled these with numbers to make it clearer for you. We have angle 1 plus angle 2 equals 180, okay? We have angle 4 and angle 3 equal to 180. So then we can say angle 1 plus 2 equals 3 plus 4, since they're both equal to 180, and that was substitution. But now I'm going to say the measure of angle JXK plus the measure of angle JXY equals the measure of angle JYL plus JXK. All right, and the reason I'm doing these numbers is because it makes it easier. 1 plus 2 equals 180, 4 plus 3 equals 180, therefore 1 plus 2 equals 4 plus 3. Much easier than saying all those letters. So JXK is 1, angle 1. JXY is angle 2. I'm now saying that angle 1 plus angle 2 equals JYL, which is 4, plus JXK, which is angle 1. Okay? Or not JXK, JXY. Let's see, JXK plus JXY equals JYL plus JXY. Here, let me not erase that. I just needed to put the Y at the end here. JXY. And what is JXY? JXY is 2. Okay. Get rid of this 1. Boing. Okay, so this is 2. So look what we just did. JXK is 1. It's got 2 marks. It's congruent to 4. It's got 2 marks. 2 marks, 2 marks, or arcs. 1 is equal to 4. 2 is obviously equal to itself. So 1 plus 2 equals 4 plus 2 because 1 equals 4. And where did we say 1 is equal to 4? JXY is 2. That's up here. And JYX is 3. So 2 equals 3. So if 2 equals 3, 1 has to equal 4 because of this step right here. If 2 is equal to 3, 1 has to be equal to 4. So 2 is obviously equal to itself, so now 1 is equal to 4. Ay caramba, it is easier with numbers, but it's still a mind boggler, yes? So anywho, we have angle JXK plus KXY, angle 1 plus angle 2 is equal to angle 4 plus angle 1. Or 2, I'm sorry, 4 plus 2. 1 plus 4 equals 4 plus 2. 1 plus 2 equals 4 plus 2. Therefore, we can conclude that we know 1 is equal to 4. All right. And this is also substitution, property of equality. Substitution. All right. Okay. Now I can say the measure of angle JXK equals the measure of angle JYL. What numbers are those? JXK is 1, JYL is 4. So that's from here. So I can now say 1 plus 2 equals 4 plus 2. Therefore, 1 has to be equal to 4. Okay, and that's a long statement. So let me pause this and bring it in as a text. So that is angles supplementary to either the same angle or congruent angles are equal in measure. Okay. All righty, so where are we now? Let's just pause for a second and see if we can label anything up. JXK is angle 1. That is right here. That is right here. JXK is congruent to, let me use 3 marks too, because I've already used 1 here and 2 here. And I haven't labeled this as 2 and this as 2. So there's an angle. So now I am saying JXK is congruent to JYL. All right. So that is this and this. So that's an angle. So I have a side, I have a side, I have an angle. There is no SSA. We're not done yet. Okay, so what can we say now? This is L. And this is J. No, it is not. How did I erase those? All right, this is L. This is Y. This is X. Okay, so we have the measure of angle JXK equal to JYL. All right. Now we can say JK is equal to JL, which we've already done up here. That was a given. the measure of angle K equals the measure of angle L, why? If you look at this big triangle, okay, JKL, that mark is congruent to that mark. So JK is congruent to JL because, so that makes that an isosceles triangle. So now I can say the measure of angle K equals the measure of angle L. And the reason is right here. Base angles of isosceles triangles are congruent. Okay, so now I know that this angle is equal to this angle in measure. They're congruent. Now I have two angles in a side. So now I can say the triangle, now I can say triangle JXK is congruent to triangle JYL by angle, side. And we're finally done. Prove XK equals LY. Corresponding parts, congruent triangles are congruent. Or if you prefer, corresponding sides of congruent triangles are congruent. Okay, we had angle, angle, side. We knew the two triangles are congruent. Therefore, every corresponding part is congruent. Therefore, we can now say this is congruent to that. Okay, here's proof number 4. I've already color coded it so I can pull it apart. All right, so let's look at the givens. AD is perpendicular to DR. Label the diagram. That's a right angle. Comma, AB is perpendicular to BR. Label the diagram. AB perpendicular to BR. So those are right angles. So we're talking about this triangle and this triangle. And as I stated, they are right angles. Right angles. This is A. Let's do it in black. This is A. This is A. This is B. This is R. R. D. Okay, so there's the two right angles pulled out of the diagram. And so now we can say that they are triangle A, D, R, and triangle A, B, R, are right triangles. Okay? And, oh, this was given. And this is definition of right triangles. Okay? So we now know those two are right triangles. Okay. So now what's the other given? AD is congruent to AB. Label the diagram. AD congruent to AB, AD congruent to AB. Okay, this is going to be nice. That is a given. Very simple, proving these two triangles congruent. Okay. As you can see, this side is shared. I meant to use purple. AR is congruent to itself. So AR equals AR reflexive property. Okay, beautiful. Look what we have here. This is a leg and this is a hypotenuse. This is a leg, and this is a hypotenuse. Triangle ADR is congruent to triangle ABR by the hypotenuse leg theorem. All right, that wasn't too bad. Good start. Okay, so we're trying to prove angle DCR is congruent to angle BCR. It's these angles down here. So let me pull these out now. So now we're talking about this triangle and this triangle. And let me label them. So this is D, and this is R, and this is R, and this is B. And these down here are your C's from here. So these are the two triangles, and we are trying to prove that DCR is congruent to BCR, these two angles down here. Well, the right triangles are up against these, and so what can I get from these two being congruent and these? So it's obviously the DR and the BR are shared right here. So now I can say that DR, side DR from my right triangle, I can say DR is congruent to BR. Reason, corresponding sides of congruent triangles are congruent, or corresponding parts of congruent triangles are congruent. Okay. Alrighty, so now let me label that. So now let me use blue in this one, so I only have to use one marker. No, there's a blue triangle, so let's use green. So what I just said was DR is congruent to BR. So that's right here is congruent to here. Now let's not say this is congruent to this because I use one mark. I'm just changing colors so that we know they're different. Okay, so we have a side on that triangle. There's another side here, and we know, okay, I see what's going on. Alrighty. So now I can say the measure of angle ARD, the measure of angle ARD is congruent to the measure of angle ARB is equal to the measure of angle ARB. Let me just put this extender here, move it over. There, that's close enough. Okay, so ARD is equal to ARB in measure because, again, corresponding parts of congruent triangles are congruent. In this case, corresponding angles. So now I can say that this angle is congruent to this angle because these two triangles are congruent. So that is right here and here. And this ARC is a straight line, and there's a linear pair. So now we have to approach it that way. So now I'm going to say the measure of angle ARD plus the measure of angle ARD DRC equals 180 degrees. I'm going to do the same over on the other side. Now I'm going to say ARB plus BRC, the measure of angle ARB plus the measure of angle BRC equals 180 degrees. Okay, linear pairs form supplementary angles. So that's what we're going to say. Linear pairs form supplementary angles. Okay, so what we're leading into here is this angle here is equal to this angle here because, so that'll be in here. That's what we're leading up to. And why is that? Well, once we say these two are add up to 180, now we can say this is equal to this. So I'm going to say the measure of angle ARD plus the measure of angle DRC equals the measure of angle ARB plus the measure of angle BRC. And that is transitive property or substitution, okay? Let's say transitive. Okay, ARD plus ARB. I'm sorry, ARD plus DRC is 180. ARB plus BRC is 180. Therefore, ARD plus DRC equals ARB plus BRC. And if I color coded those, ARB, DRC, no, ARD plus DRC is 180. ARB, BRC equals 180. Then ARD plus DRC equals ARB plus BRC. So this plus this equals 180. The blue plus the purple equals 180. Therefore, the red plus the green equals the blue plus the purple. Okay, hopefully that didn't confuse you. I tried to make it clear. Red plus green equals 180. Blue plus purple equals 180. Therefore, red plus green equals blue plus purple. Say that 3 times fast. Okay. So once we do that, we can now say that the measure of angle DRC, which is green, equals the measure of angle BRC, which is purple. So the measure of angle DRC equals the measure of angle BRC. So if we look in the diagram, it's going to be clearer. The measure of DRC, that's this one, is equal to BRC. And that's what I was saying we're leading up to. And the reason for that is angles of supplementary to either the same angle or congruent angles are equal in measure. Did I use that up here? I think I erased it. All right, let me get that. Okay, these are really lengthy proofs that they're giving us. So there it is, angle supplementary to either the same angle or congruent angles are equal in measure. So now angle DRC is congruent to BRC. So therefore we now have a side. I haven't been labeling these. We have a side and we have an angle. So now we just need another side or another angle. But if you see, RC is equal to itself. Oh, look at that. So now I can say RC equals RC, or is congruent to RC. Reason, reflexive. Okay, so now this is equal to this because it's equal to itself. Now I have S, included angle, S. So now I can say triangle DRC is congruent to triangle BRC. Reason, side, angle, side. And now we can prove angle DCR. The measure, oh, it doesn't say the measure. It's not saying they're equal in measure. It's saying they're congruent. So let me redo that. Angle DCR equals, or is congruent to, angle BCR. Corresponding angles of congruent triangles are congruent, and we are done. Okay, page 3 brings us to proof 5, and here's another proof with all kinds of triangles in there. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles in this diagram. So we need to determine which ones are relevant to what we're trying to prove, right? So sometimes getting started, it may be the biggest problem with proofs. So let's take a look. Look at what you're trying to prove. Bx equals cy. Bx is in this little orange triangle. Cy is in this little green triangle. And then when I go up and look at the other givens, AR equals AS. That's in the red and blue triangle. And the red and blue triangle overlap the green, and the BR and the CS are in the little triangle. So that's why I have these diagrammed like so. So I'm imagining that we're going to be using these triangles to prove this. So let me bring them down because of all the parts that were in all the givens were components of these triangles. So let me label this before I continue. So this is X, this is B, and this is R, and this is S, and this is C, and this is Y. And then we have these triangles here that overlap that little triangle. So I'll bring these down. And this was A, and this was A, C, S, R, and B. So BR, this and this are the same, this and this are the same, and angle B is the same, and angle C is the same, and so on and so on. So that's why now we're looking for a portion of this and this, so that's why we have to get to these little triangles. All right, so let me just bring in my statement reason table. Okay, so there it is. So now we're going to look at the givens. AR equals AS. Label the diagram. AR equals AS. Oh, that tells me right there, triangle ARS is isosceles, so we're going to lead up to these angles being congruent. So AR equals AS, like so. All right, and then we have BR equals CS. BR equals CS. That's here, and it's also in the little ones. Okay, so I have two sides in this bigger triangle, the red and the blue. We have a side and a side. If we get this R equal to S, then we will have a triangle congruence. So the measure of angle ARS is congruent to the measure of angle ASR. That's what we're going to say next because this is an isosceles triangle, yes? So then we can say that this was given. And then we can say the measure of angle ARS equals the measure of angle ASR. Base angles of isosceles triangles are congruent. Okay? These angles are not in any of these triangles. This R is way over here, and this angle would be like right here, and here is what we're talking about when we explode the diagram. Okay? So they're not in either of the triangles. All right, so with that, then we have to do the linear pair stuff, yes? So now I'm going to say ARS plus ARB, yes? The measure of angle ARS plus the measure of angle ARB equals 180 degrees. So ARS plus ARB. We're going to say the same over here. ASR, the measure of angle ASR plus the measure of angle ASC equals 180. Okay. Linear pairs form supplementary angles. Alrighty. So now I know that angle ARB equals ASC. So how are we going to say that? The measure of angle ARS plus ARB. See how this equals 180? Let me try color coding it again. ARS plus ARB equals 180. ARS plus ASC equals 180. So oops, I used the same color for two different. So let me change the color of this. Okay. ARS plus ARB equals 180. ASR plus ASC equals 180. So all we're doing is these linear pairs here and here. So since they both add up to 180, they're equal to each other. So now I can say the measure of angle ARS plus the measure of angle ARB equals the measure of angle ASR plus the measure of angle ASC. Okay, and if I continue to color code those, ARS, or green plus blue, is equal to orange plus purple. Okay, and that is, we could say, what, transitive property? Yes. Alrighty, so ARS plus ARB equals ASR plus ASC. All right, so now we can say ARB. Remember up here we said ARS equals ASR. So if these two are equal, then these two have to be equal if they're going to add up to 180. See that? All right, so now we can say the measure of angle ARB, the blue equals the purple. The measure of angle ARB equals the measure of angle ASC. So let me finish color coding this because ARS is right here and ASR is right here. So green equals orange. So green equals orange. So something that's equal to another, if you add something else to it and you get the same product or sum, then these two have to be the same. If this was 100, this has to be 80. And if these are both 100 because they're equal, these both have to be 80. All right. So why is ARB equal to ASC? That's the subtraction property. So 180 minus that equals that, 180 minus that equals that, and they're both equal. So let's say substitution. All right, so now let's label our diagram. ARB, which is here, is equal to ASC. Well, isn't that beautiful? I can now say the triangles are congruent. Okay, because BR is equal to CS, that was a given. So now I can say triangle ARB is congruent to triangle ASC. Reason, side, angle, side. There's a side here, there's an included angle here, and there's a side there. Okay. All right, so we have the triangles congruent. Now I can say, let's see, now we want to transfer what we know here to here. So remember, this triangle goes right there. So you see that? Okay, so angle B looks like it's the same, and we're going to prove that. So now I'm going to say angle ABR is equal to the measure of angle ACS. Reason, corresponding angles of congruent triangles congruent. Corresponding parts of congruent triangles are congruent. So then I label my diagram. ABR is congruent to ACS. And if I do that up here, that's my XBR. ABR is right here. Yes. XCS is there. So that's this little angle here and here. So now I have a side and an angle in these little triangles. Okay, so then what are we going to do? Let me see. Okay, we have not addressed the rest of the givens, the perpendicular stuff. So let's do that now. Let's use, I don't know, red. Now it's saying RX is perpendicular to AB. RX perpendicular to AB is right there. SY perpendicular to AC is right there. Okay, we're not working with that little triangle there, so let me redraw those. You can put your right angles on either side or both sides. Okay, so that's saying that is that. So that's saying angle X, if you will, is congruent to angle Y, or angle AXR and AYS are both right angles. So that's what we're leading up to in this here. So I'm going to say the given RX is perpendicular to AB and SY is perpendicular to AC, and that was a given. Okay, so with that being said, I can now say the measure of angle BXR, the measure of angle BXR or RBX, measure of angle BXR equals 90 degrees. And also the measure of angle, if I say BXR, I'm going to say CYS equals 90 degrees. Okay, and the reason is definition of perpendicular segments. They form right angles. Okay. All right, so I now have two angles and a side. So now I can say triangle BXR is congruent to triangle CYS. Reason, angle, angle, side. Okay, beautiful. Now I can get right to my BX equals CY. That's what we're trying to prove. BX is a side in a congruent triangle setup. BX equals CY because corresponding sides or parts of congruent triangles are congruent. And we have proved BX equals CY. Okay, this is proof 6. Okay, this is a lot of proofs to do in one lesson, 6 proofs, and they're very lengthy proofs, but let's just plug along. Let's go. All right, so in this diagram, I looked at what we're proving. NY equals NM. New York equals New Mexico. All right, so NY is this segment here, and NM is this here. So I pulled those triangles out because we're going to try to prove those two triangles are congruent and then use CP/CTC. All right. Hey, what happened there? Timeout. Oh, it exploded. Okay. So bring this down here and bring this over here. And let's label those. They don't look as big or the same size, but remember in geometry, things are not always drawn to scale. All right, so here's B. This was Y, and this was N. This was M. This was N, and this was A. Okay, so those two triangles, this should be stretched out a little bit longer to make it look the same as this. All right, what we're trying to prove is NY is equal to NM. So this is our goal, to get these sides congruent. But within those triangles, we have these other two triangles. And the reason I chose them was because it said that these angles were 90 degrees, and those were the only triangles that had 90 degrees in them, except these bigger ones. But let's just use these two here. Okay, so I see what's going on now. This triangle, this blue one, looks to be about the same as the green one, where the red one, they don't all look the same size in this diagram, the way they're rotated, but BNY looks the same as AYZ, which is this one. So the orange and the blue look the same, but the red one's tiny and the green one's bigger. So let's just see what goes on here. I might have to change and add to this. So this was a little triangle. This is M, and this is X, and this is B. This blue triangle was A, Z, Y. Okay, so that came from here. All right, so there's the diagram exploded up a little bit. So the first thing we're going to do is get into our givens. AX equals BX. Label the diagram. AX equals BX. BX is here. There is no AX over in any of these. Okay, so now I have an isosceles triangle. Triangle AXB is an isosceles. Okay, see if we need to use that. So AX equals BX, and that is a given. Okay. Let's see, AMB. Okay, now we're doing the other given. The measure of angle AMB equals the measure of angle AYZ, and they're both equal to 90 degrees. So AMB is already labeled, but that's the XMB, so that's this angle here, so I can label that as a right angle. And AYZ is labeled in our original diagram, and that is right here. Okay, so there's our diagram labeled up with all of our givens. They labeled that for us, and then we labeled this. Got to prove NY equals NM. Okay, so now that we've got the givens done, what can we do? Just trying to look at the diagram and find something. We have, let's see. Oh, I see right here, vertical angles, and that's AXY. So this is no, we didn't use triangle AXY. So BXM and AX, yeah. So we're going to say that these two angles are congruent. Vertical angles are congruent. Angle, the measure of angle, BXM equals the measure of angle AXY. Reason? Oh, this was given. Vertical angles congruent. Okay. So let me see. Oh, I see. This is a right angle here because this was a right angle. So now I have these two triangles are congruent. AXY. I did not make an AXY. So let me make an AXY. Okay, so here this purple triangle is AXY. AXY is right here. So we're proving that triangle AXY, the purple one, is congruent to triangle BMX, which is this red one. They don't look it, but it's just the way the diagram was, or maybe I didn't draw this very well. But anyhow, this is a right angle. AYX is a right angle because we were told that AYZ is a right angle and they're on a straight line. Okay, and now we just got vertical angles are congruent. So that's this angle here, and it's congruent to BXM, which is right here. So I have angle, side, because BX is congruent to AX, and that is right there. So it's angle, side. So now we have two congruent triangles. So as I said, I broke up the diagram, but there was another triangle I needed, so add it to it, no big deal. So now I can say triangle BMX is congruent to triangle AYX. And it's because of angle, side. Okay, so that's the first triangle we found congruent. So now we can use its parts to that in corresponding parts if we need it to continue. Okay, so we have BX here, we have XY here. What do we know about XY? Well, we know XY is congruent to XM. We haven't said it yet, but we do know that. So let's say that now. XM is equal to XY. Let's change color for this next step. Okay, XM is this side right here. It's equal to XY, which is right here. Reason, corresponding sides or parts of congruent triangles are congruent. Okay, so that's XM, which is this piece here, is congruent to XY. Let's use 2 marks in this one. Okay, so now I have this piece plus this piece. BX plus XY is going to equal AX plus XM. Okay, BX plus XY equals AX plus XM. In other words, BX plus XY is the full length, BY, and AX plus XM is AM. And the reason those are congruent is segment addition property. Okay, this piece plus that piece equals this piece plus this piece. If you know these two are already congruent, we found these two pieces congruent, add the two congruent pieces together, and the full length is congruent. Okay, so we have BY equal to AM. And actually that was segment addition here, and this would be substitution. Okay. And now I can say angle BYN is 90 degrees. Let me change colors again because we're on to another topic. No, let's leave it. All right, where was I? Measure angle BYN is 90 degrees. BYN is 90. Okay, vertical angles are congruent. All right, they're straight across from each other. Okay, so now I know BYN is 90 degrees, which is right here. BMX is 90, got that. AYZ is 90, got that there. Okay, AMB is 90 degrees. AMB would have been over here. So AMN is 90 degrees. We'll get to that, I think. So AMB plus AMN equals 180 degrees. Okay, AMB plus AMN equals 180. That's the linear pairs form supplementary. Okay, linear pairs are supplementary. So now I know that AMN is a right angle, and I've got that right here, AMN. Okay, this one's really confusing, but we'll keep looking. So now I can say AMN is 90 degrees. The measure of angle AMN equals 90 degrees. And that is subtraction property of equality. If the two add up to 180 and this is 90, then that's got to be 90. Okay. MNY is equal to itself. So that's in two triangles. Okay. Let me change to blue. Measure of angle MNY is right here. It is, MNY is this angle here. See, MNY continues up to A, that is this triangle. It's equal to itself, which is in the triangle BNY. So BNY is right here. So we're working with the orange and the green triangle now. Y is 90 degrees, M is 90 degrees, and N is equal to itself. So the measure of angle MNY equals the measure of angle MNY. Reflexive. When triangles overlap, you can use those parts as reflexive. So now, what else did I have? BY equals AM. There it is. So we already said that BY equals AM. Right up here, BY equals AM by substitution, adding the parts up. BY equals AM. So now we have two triangles, angle, angle, side. So now I can say those triangles are congruent. So triangle BYN is congruent to triangle AMN by angle, angle, side. And NY is in that triangle and MN is in that triangle. So booyah, we are done. NY is here, MN is here, NY, MN. That's what we're trying to prove. NY is equal to NM. Corresponding parts of congruent triangles are congruent. Ooh, that was a good one. Okay, page 4 brings us to the end of lesson 27. Finally, proofs. Ooh, go to your problem set.